122 years of practical flight, the only thing that hasn't changed is the air itself. The evolution has been continuous, but many experts predict that we're on the cusp of a step change in aerospace, driven by the confluence of new materials and propulsion technologies, guided by innovative computational techniques, including AI. And all of this is happening within a new imperative: sustainability. I was joined at the Engineering Roundtable by 4 experts who discussed everything from disruptive technologies to cultural change in this $350 billion global market. Take a look. What are the current challenges in the aerospace industry as we see it now? Duncan, can I start with you? We talked about sustainability, but there's a lot more sort of facing an airframer or power plant maker these days.
Yeah, I think the word or the phrase on everybody's lips at the moment, Jim, is the SAF, and SAF can get us to low emissions, but it doesn't get us to zero. So fundamentally, people are looking at electric propulsion units and ultimately a hydrogen electric propulsion train. Most conventional aircraft, electric doesn't provide sufficient power at the moment. So people then naturally move to hydrogen. The trouble with hydrogen is it's not so good for storage in a conventional wing. Usually the cryogenic storage requires some sort of flask. Wings aren't good for that geometrically, so you're looking at taking up space in the fuselage, and that would actually reduce the amount of seats you can get and fit people in the aircraft. So there's a few challenges that conventional aircraft have got. Our little aircraft has got some advantages here, and that's mainly the abundance of space reservation we've got. So we are quite happily considering hydrogen, electric first, then hydrogen ultimately, but space reservation and trying to integrate the new propulsive technologies with traditional airframe design is a big challenge, Jim.
Aziz, one factor I've noticed is that the industry appears to be in some ways going back to what it was a century ago. Small entrepreneurs, 5, 6 people developing air taxis, urban air mobility. There's some question now as to how is that going to work in an environment that is used to consolidation, the other way around, large airframers, fewer, bigger companies. Are we basically seeing now a proliferation now of these tiny players, or will they, do you think, consolidate into something that we know now?
Yeah, I think that's mainly innovation booster that's happening today. I think overall it's just like enabling all that new type of small structures is just allowing engineers to think without limits to new technologies, new materials, new processes to open up for new ways of flying. But eventually or ultimately, I think this is going to consolidate again later on, where when you see the volume of the aircraft that is needed and the demand that's out there.
Marunas, composites are historically been a very expensive way to make airplanes. Is it always going to be that way?
Honestly, I don't think we can make the large aircraft the way we've been manufacturing in dozens of people around the tool, hanging from cherry pickers to reach the middle. And also, if you look at the electrical vehicle, the urban air mobility, that trying to build thousands of airplanes, I don't think we can do the way that we've been doing. So the automation is going to be a key part of it.
Keith, what are you seeing? What do customers approach you with? Do they bring up sustainability as something that's first and foremost? I mean, this is an interesting industry because efficiency has always been paramount. So it seems ironic to me that we could talk about sustainability in an industry in which really maximizing the amount of performance out of every drop of fuel has always been a factor.
Jim, I think you're absolutely right. From my perspective in our industry, we're undergoing nothing short of a revolution right now. The tools and technologies that we use to design the products and the performance of the processes that build these things, the tools that we use have moved on significantly from the old processes of the past, which are still grounded in very traditional notions of creating something physically. Today, with the use of AI, with digital simulation, design, digital twins, etc., we can move a lot faster than that. That's opening up the doors to more innovation. It's opening up the doors to new entrants. We can do things faster. So I see a tremendous improvement. I think what you're seeing from sustainability perspective, if you ask the average engineer on the street, they will say we've always been doing this. I think the big difference now, though, that there is an imperative that everybody can see to make the change. It's not just good enough to do it, you have to go above and beyond. And that's creating some of this demand, whether it's government regulation, whether it's improvements in what customers are requiring and demanding. But that's in itself driving that new innovation, those new entrances. So it's a bit of a vicious circle. It was a very exciting time.